that in the poster activity on identities, one example D is a little bit daunting. Here's the word daunting. Daunting. Daunting really means a little bit scary. It's overwhelming. Okay? Some of you may look at this and be like, oh my God, what does Shauna want from us? She's torturing us. So I wanted to do a similar example for you so that this does not seem as daunting, does not look as scary. Okay? Here you have expressions, rational expressions we call them. You have expressions with variables in the bottom, in the denominator, and I'm going to do a similar example for you over here. So I have this equation, 3x squared over x plus 11 plus negative 1 over 2x to the third. And on the other side, I have 6x to the fifth minus x minus 11. And on the bottom, I have 2x to the fourth power plus 22x to the third power. Now the question is does this represent an identity? Does it represent an identity? What was again an identity? An identity is an equation which, if we substitute, we can substitute the variable with no matter what number, the two sides are still going to be equal. How can we find out if this is an identity, if the two sides are the same? Well, we need to change one of the sides to make it look like the other one. If you remember, we talked about gemelos, right? So we want to see if those two sides are gemelos, if they're twins. Best thing to do is when you have fractions is to combine those two fractions together. So if you remember how we add fractions, I'm going to give you a little reminder. If we have 1/2 plus 1/3, I cannot really add 1/2 and 1/3 because 1/2 represents half a pizza and 1/3 represents one slice out of a pizza that's cut in 3 parts. If you notice, those slices are different size, so I just cannot add them because they're different size. This slice is bigger than this slice. How can I add them? So I have to make the two slices equal. So I have to make the denominators equal. To make the denominators equal, I'm going to multiply here by 3 and here by 2. So that I don't change the fraction, I want to multiply also the top by 3. So the 3's can cancel out. And I can multiply here the top by 2, so the 2's can cancel out. In this case, I don't want them to cancel out because I want to have 6 on the bottom. So I get 3 over 6 plus 2 over 6, and this is equal to 5 over 6. Yeah, so pretty much I took that piece and this pizza and I cut it in 6 pieces, and I took this pizza and I cut it in 6 pieces, and now I have 1, 2, 3, 4, 5 pieces out of a pizza that's cut in 6 pieces. And guess what? This is cut in 6 and this is also cut in 6. Those pieces are actually equal size. I drew them it's a little bit ugly the way I drew it. It's like this one should be a little bit further up. But those pieces are actually the same size here and here. Okay? So I try to give you a little rationale, reason how we add fractions and why we need the denominators to be the same. Think always of pizza. The slices have to be the same size. That's why the denominators have to be equal. Well, we've got to do exactly the same thing here. We need to make sure that this denominator over here is equal to this denominator over here. And the best thing to do is just multiply this denominator by 2x to the third power and multiply this one by x plus 11. And if I do it to the bottom, I gotta do it to the top so that I don't change the fraction. And here I'm gonna do x plus 11. Now I'm just gonna deal with the left side. I'm gonna try to simplify the left side. So I'm gonna continue here. On top, I can get rid of the parentheses because the only thing I have is multiplication. All these numbers are just being multiplied together, so it doesn't matter which ones I do first. I don't really need the parentheses. Here, let me just copy it like for the time being so it's clear what I have. I will keep the parentheses because I have a plus sign and I have multiplication as well. Okay? Here on the bottom, I've got the same thing. Whether I write x plus 11 first or 2x to the third first, it doesn't really matter. So I'm just going to write it. Actually, 2x to the third over x plus 11 is better. Okay? And over here, I will keep my parentheses because I have multiply and then I have add. Now, on top here, I'm just multiplying 3 times 2, 6. X to the second power times x to the third power is really, I have 2 x's and 3 x's, I have a total of 5 x's. Now, I've got a plus here, but I have a minus in front of the 1. Let's open these parentheses. Let's distribute the negative 1 to x. I get minus 1 times positive x becomes negative 1x, or just negative x. And then negative 1 times positive 11 is just negative 11. What do I get on the bottom? Let's just copy it for now. 2x to the third over x plus 11. If you notice now, the denominators are the same, so I just can write them together under the entire expression. Now, we need to simplify the bottom. There's nothing I can do in the numerator, but I can take 2x to the third power and I can distribute it to x and to 11. Here's what I get. 6x to the fifth minus x minus 11. And on the bottom, I get 2 times x to the third times x to the first. So I have 3 x's and 1 more x. This gives me 4 x's plus 2 times 11, 22 x to the third. Let's look now at the expression I had on the right side originally. I'll copy it over here. 6 x to the fifth minus x minus 11. And on the bottom, 2x to the fourth plus 22x to the third. Are those two sides identical? Yes, they are. Therefore, this is an identity. So hopefully this example taught you how to add those complicated expressions which have variables in the denominators. Just think about adding fractions. You're following exactly the same procedure. Hope this helps. Let me know if you have questions.